When Neil Armstrong and Buzz Aldrin left the lunar surface in 1969, they did not know whether their footprints would last centuries or vanish in a season. The moon, it turned out, was more stubborn than expected. Its airless silence preserved every scuff and scrape, a record of humanity's first steps off Earth. That discovery, that something fragile could endure in such a harsh place, quickly transformed how we thought about exploration. In a way, water on the moon carries the same quiet promise. Long assumed to be bone dry, the moon has surprised us by holding on to something essential, hidden in shadows and grains of dust, the kind of discovery that reminds us the story isn't finished yet. In today's video, we'll examine why lunar water matters for science, for exploration, and for our long-term presence beyond Earth. We'll consider how it changes what we thought we knew and how it might shape what comes next. Let's begin. Hello, I'm Gene Botkin, and before we wade too deeply into lunar trivia, I'll pause to say this. If you appreciate a little civic-minded reflection mixed with deadpan reporting, then you can discreetly click like and subscribe to the channel. I promise you, nobody will come knocking to check. Now, the story of lunar water began quietly, which feels appropriate for the moon. In the late 1990s, a few cautious scientists noticed faint signals from orbit suggesting hydrogen at the poles. This did not prompt ticker-tape parades. It prompted raised eyebrows and muttered requests for more data. And a decade later, missions like India's Chandrayaan-1 and NASA's L-Cross finally confirmed the suspicion. They slammed probes into the moon and, with a kind of grim satisfaction, kicked up a cloud of dust and ice crystals. It was official. The moon was not completely dry. This discovery was mildly inconvenient because textbooks had insisted for years that the moon was arid. A dead rock, they said, good for planting flags and collecting rocks, but inhospitable to anything as unruly and unpredictable as water. Instead, we found ice lurking in shadowed craters so cold that they could freeze the ambition out of a venture capitalist. And what makes this interesting, beyond the satisfaction of catching the textbooks in a lie, is that the water probably doesn't even come from one source. Some arrived by comets, and some may have been cooked up by the solar wind reacting with lunar dust. The details are still debated, which, in science, means that everyone is quietly confident that they're right and everyone else is wrong. And so, what began as a faint whiff of hydrogen evolved into a modest revelation. The moon, despite its best efforts to remain dull, had managed to hold on to something that we thought was impossible. And from here, the question became what any sensible person would ask next. What good does it do us that there is water on the moon? Now that we've established the moon is not entirely useless, let's talk about what we can actually do with its water. And since you're already here, quietly considering the utility of frozen lunar sludge, you might as well like and subscribe. It's the sort of small gesture that keeps these conversations civilized. So, lunar water is more than a geological oddity. It is a practical asset. If we can extract it, then it could supply drinking water, oxygen to breathe, and hydrogen fuel for rockets. That is more appealing than shipping every drop from Earth, which currently costs roughly as much as a Picasso on auction and is only slightly less irritating. The concept is called in situ resource utilization, and that is polite engineering jargon for stop dragging everything up there from here. If astronauts can melt ice and split it into oxygen and hydrogen, then they can stay longer, move farther, and stop relying entirely on Earth, which, for an ambitious species, is the entire point. Of course, it won't be easy. The ice is mixed with dust and rock, buried in places where temperatures plunge to mind-numbing lows. Mining it without vaporizing it or freezing yourself in the process is an engineering puzzle, and one that promises to produce a fine collection of expensive mistakes before it produces water. Still, the very idea of lunar water shifts the moon from being a kind of oversized museum exhibit to a functional outpost. It suggests that future missions could move beyond short visits and begin building something far more more substantial. And once people realized that water might enable that, it became harder to dismiss the moon as yesterday's news. From here, the discussion turns to an inevitable question. What happens when everybody wants a drink? As soon as people heard that there was water on the moon, the conversation predictably veered from science to squabbling. And this is what happens anytime humans find something remotely useful. At first, the moon's south pole, which is where the water is, was simply a quiet and cold corner of the solar system. But now, it is looking more like an exclusive club with no dress code and no bouncer. The United States has its Artemis program aimed squarely at the polar regions. Meanwhile, China has made its own South Pole ambitions perfectly clear. And even private companies are circling like guests who weren't technically invited but are hoping nobody notices. Legally, the Outer Space Treaty, which is a real thing, insists that no one can own the moon, which is adorable in theory. But in practice, whoever puts equipment on the ice and keeps it running effectively controls the resource. And it is hard to enforce lofty ideals from 240,000 miles away when somebody is already operating a drill in the crater that you are eyeing. This polite fiction of no ownership is beginning to strain under the weight of real interests. Water means fuel, which means cheaper missions and more capability. Whoever controls the water effectively controls access to much of the moon's potential. And once that becomes obvious to everyone, the so-called spirit of international cooperation begins to resemble a room full of cousins arguing over a will. Of course, this isn't necessarily bad news. Competition has a way of making things happen. The moon has been ignored for decades because it was politically uninteresting, but the discovery of water changed that. Suddenly, this quiet gray ball in the sky is no longer a backdrop for poetry, but a stage for power plays. And that raises another question worth asking. How much water is there, really, and will it last? Let's take a closer look. So, once the politicians and engineers finish measuring the moon like it's a prize hog at a county fair, the scientists quietly step back in and ask the questions that actually matter. For all the talk about mining ice and fueling rockets, nobody is entirely sure of how much water is there or how it got there. Some of it may have arrived courtesy of ancient comets slamming into the surface billions of years ago. Some may have formed more recently as the solar wind bombarded oxygen-rich dust and left behind hydroxyl and water molecules. Whatever the case, this is not an academic quibble. If the water is ancient and finite, then we risk depleting it before we understand what we're doing. And if it is actively replenished by ongoing processes, then we can plan for a more sustainable, although still precarious, presence. But at this stage, the maps of lunar water are still more guesswork than guarantee. We also do not know much about how evenly it is distributed. Some craters may hold significant ice deposits. Others may offer little more than damp dust. Even the temperature extremes of the shadowed regions pose a challenge. One robotic lander, miscalculating its descent, could accidentally cook the ice it came to study. And beyond the practical concerns, the moon's water holds clues about our own solar system. Learning how volatiles accumulate and endure on airless worlds helps refine the search for habitability elsewhere. And every sample dug out of a crater tells a small story about cosmic history. The engineers draw up plans to harvest it, and the diplomats draft statements about sharing. The scientists remain in the corner, quietly fascinated and increasingly skeptical that anyone fully appreciates what is under their boots. This scientific uncertainty leads to the last and most important question. What happens next? Next comes the part where ambition meets reality, and where engineers discover whether their bold plans were brilliance or comedy. Over the next decade, space agencies and private companies will send robots to the lunar poles to scout and test extraction methods. Some will work, some will fail in ways that produce memorable conference presentations, and eventually, astronauts will follow, tasked with staying longer and doing more than planting flags and collecting rocks. But none of this will be quick. The technology to harvest ice efficiently, keep it from sublimating, and store it without wasting half of it in the process is still in development. The political consensus to fund long-term operations will be tested repeatedly, because the moon has a way of exposing hubris in even the most serious programs. But what is perhaps most striking is how quickly the conversation has shifted. For decades, the moon was considered a dead end, a nostalgic detour on the way to Mars. But now, thanks to a few faint signals of ice in the shadows, it has regained its place in the story. Suddenly, lunar water is being factored into mission designs treaties, international agreements, and budget proposals. This does not mean that the moon is going to become a bustling outpost, but it does mean that serious people are working seriously to make it more than a museum piece. Next, we'll step back and consider what all of this says about where we are heading. Thus far, the moon has been patient with us. First, we treated it as a canvas for ambition, and then as a relic of past glory. But now, with the discovery of water, we seem to be treating it at last as a place that matters on its own terms. And there is something quietly encouraging about that. Even in the coldest and most inhospitable corners of our nearest neighbor, there is still enough promise to pull us back, enough to make us plan, argue, and invest in something beyond ourselves. If nothing else, the search for lunar water has reminded us that the story is not over, and neither is our capacity for persistence. Thank you for watching, and if you haven't already, then consider liking this video and subscribing to the channel so that you do not miss future developments in the new space economy. With Elenarda, I'm Gene Botkin. End transmission.